Hey guys, welcome back to my channel Success Engineering Official. As you can see, this project we have completed. This is the plumbing project, drainage system, drainage and water supply. This is the complete project we have done. So our last topic is balance in this project is pump head calculation. That means this transfer pump head calculation. Okay, so we are going to do the transfer pump head calculation today, and we have to got this pipe size, also this riser pipe size. We can calculate from this. Okay, so before I start this video, I would request you guys, please do subscribe my channel and hit the bell icon, as well as you have to share and like my video, share with your friends, and please like and comment to my video. Okay, so let us start now. So as you can see, this is the riser diagram. Okay, and this is your overhead tank. Okay, and this is your underground water tank, and this is transfer pump. Okay, this water is this pump is transferring water from this underground tank to this overhead water tank. Okay, so for this to calculate this riser piping and this pump head for this transfer pump, we have one format. I will let us open this transfer and booster pump. Okay, so we have this transfer pump head calculation. Okay, so for 2 storage, simply I did this. Actually I have done this for the 5 storage building. So 2 storage building Dubai. Okay, this is for the Dubai project actually. Okay, so first of all, in this format we required a storage capacity of roof tank. That means overhead water tank sizing. Okay, overhead water tank size in cubic meter. So we have calculated for this project. So you can see here this tank sizing for 2 storage building. So this is our calculation we have done, but you have to take the actual area. Okay, actually we have only we have assumed this area, but we have not calculated. So you have to calculate the actual area as per from the drawing. Okay, we just assumed this. So we got this. You can see this is domestic underground water tank sizing in liters, 1.5 days. That means this one, and this is the domestic underground water tank sizing in cubic meter. So this is length into width into height. So 2.95, and this is domestic overhead tank sizing in liters. Okay, and this is in cubic meter. So we need in cubic meter. So this is 0.97 cubic meter. So what you will do, you have to simply enter here 0.97 cubic meter. Okay, assume a filling time in 1 hour. So you need to assume this, how many times you require to fill the tank. Okay, so I am assuming 1 hour my tank is going to be filled. Okay, so rate of filling is cubic meter per hour. That means the cubic meter, whatever the size of the tank, divided by hours. For example, I have to consider 2. That means I have to divide into 2. Okay, so more time, it will takes more time. Okay, so I just assuming 1 hour. It will depend, 1 to 2 hours we are assuming as per the tank size. Okay, so I am assuming 1 hour. Okay, so this is already based on formula, so it is already fixed. That means 0.97 divided by 1, I am getting 0.97 cubic meter per hour. So rate of filling in GPM. So this is in cubic meter per hour. So we need to convert into the GPM. So 1 cubic meter, as you can see this one, 1 cubic meter per hour is nothing but 4.4 GPM. Okay, so simply you have to multiply this value into 4.4. Okay, so we are getting here 4.3 GPM, gallon per minute. Okay, and then from these two value we can get the pipe size. Okay, so from the chart. Okay, so GPM, we have the GPM, and this is the transfer pump, that means the force system. This that means we have to assume the velocity 4 fps. So we have the velocity 4 fps and we have the GPM, so we can get the pipe size. So let us check here the IPC plumbing code. We can found the pipe size from page number 63. Okay, not 63, we have to check the where is the graph. Okay, there is graph for the smooth pipe, so we need to check that one. And from that graph we can found the pipe size. Okay, where is that graph? Let me check. Is not found. We have to check, it's here only, but we need to check. I don't know, I don't remember the exact page number, so let us search for that graph. Okay, yeah, it's here. Yes, found here. Okay, so this is for the copper pipe, and our graph is here. Friction loss in fairly smooth pipe. So from this graph we have the velocity and we have the GPM. So GPM is how much? 4.3 GPM and 4 fps. Okay, so what you will simply take one line and draw one line parallel to this. This is inclined line is showing velocity in feet per second. Okay, so fps. So our we required 4 fps. Okay, so draw one line parallel to this 4 fps. Okay, and this vertical line is showing, this vertical axis is showing flow in GPM. Okay, you can see here flow in gallon per minute. So our flow is 4.3 gallon per minute. So this is our flow line. Okay, so draw one more line where this line is coinciding. Okay, so this is the line. So this is approximate in between 1.5 and 3/4. So you can take this 3/4. Okay, 3/4 inch, approximate 3/4 inch. So your pipe size will be 3/4. Okay, 3/4 inch. So from this drawing, your pipe size here will be 3/4 inch. Okay, this for the riser piping. Okay, then location is ground floor. Okay, from this chart. Okay, and then section A to V. Section A to V, that means we have to put here section. Okay, so we have to do the tagging. So what you will do, simply copy this one and move it down here. Okay, put it here. Simply edit this, make it A. Okay, this is your point A. Okay, and copy this, put it here. This is point B. Okay, point B. So point A to B, what will be the pipe size? Not pipe size, what will be the pipe length? Okay, so pipe size is here 3/4. Okay, assume 3/4, and flow is 4.3. So flow is 4.3 GPM, and straight pipe length. Straight pipe length, we have to take the straight pipe length how much. So for example, I am assuming this pipe is 2 meter, and from here to here 2 meter. So 4 and 2 6. Okay, and this is the 4.5 meter and 4.5. So total 4.5 into 2 plus 6. Okay, 15, and plus 2. Total is 17. So plus 2. 17 meter. Okay, from A to B your pipe length is 17 meter. Here is you can see this is asking in meter, so 17 meter. Okay, and what about in feet? So this pipe will be converted into the feet. So 1 meter is equal to 3.28 feet. So it is I am getting 55 feet. Okay, and this is the valve fittings. Okay, this is the fittings comes in the pump. I will show you where and how to get this length, and this is the quantity, how much these fittings. For example, FC is nothing but the flexible connection. Okay, this is the package, valve package for the pump. This is the fittings we are using in the pump, suction and discharge line. And this is the quantity. Okay, and this is the equivalent length of the fitting. So this length we are getting from the carrier chart, and this is total equivalent length in feet. Okay, and then this is the addition A plus B. Okay, pipe length plus fitting length. So how to calculate this? First of all, I will show you pump schematic, then you can get this how to, where is the, how much fitting is using in the pump. So this is pump schematic. Okay, so you can see this is the pump suction line and this is the discharge line. So for any centrifugal pump or any pump, we are using flexible connection in each line. Okay, suction and discharge. So this is the flexible connection is fixed near the suction and discharge. Okay, so this is flexible connection. Okay, so two numbers. Okay, so you have to put it here, FC, flexible connection, 2 numbers, and this fitting length is, we can found, we will check later on. And this is the IV. IV is nothing but the isolation valve, is nothing but the gate valve. So this is isolation valve. Okay, though a gate valve or butterfly valve is called isolation valve. So in the each line, for the to isolate the pump in case of damage, so we are installing 2 isolation valve, one in each line, suction, one in suction and one is in discharge line. Isolation valve is called butterfly valve, gate valve, all are isolation valve. Okay, wall valve, these are the isolation valves. So you can see here this suction and discharge line, there are 2 valve installed, butterfly valve, so isolation valve. Okay, 2 numbers, you can put it here, isolation valve, 2 numbers. And this is your NRV. Oh, and the next fitting is NRV. Okay, non-return valve is nothing but the check valve, and this is the strainer. In this suction line always is a strainer, and in discharge line NRV. Okay, so there is no more gate valve. Okay, so you have to delete this. check valve is one number and strainer is one number, okay, and elbow fitting is two numbers. So you can see this is the fitting, two numbers elbow, one is here and one is here. So or here is only one. For example, I am taking this example, this is for other example I think. So elbow is one number, and okay, and then we have to check the equivalent length of the fitting. So how to check this one? We need to open the fitting catalog, okay. So let us open this and go to here, YouTube materials, then plumbing, then pump head calculation, then fittings. For the 90-degree elbow, you can see this is the 90-degree elbow 2.1 3/4 inch. Equivalent feet of the pipe for various pipe size in feet, okay. So this is for the 90-degree elbow 3/4 inch 2.1. So what you will do for the elbow 2.6, or you have to enter the 2.1, okay, and then a strainer. So for the strainer, let me open another fittings chart. So we have this, okay, valve losses in equivalent feet of the pipe. So you can see here, this is the strainer, Y strainer, gate valve, globe valve, gate valve. So this is the nominal pipe or tube size. So our pipe size is 3/4, okay. So 3/4, and this is the, for example, how to calculate. I will show you how to get this value. Simply delete this, okay, and what you will do, first of all, you have to mark the pipe size. So our pipe size is 3/4 inch, okay, and then we required to found the fitting length for the isolation valve, that means the gate valve, okay. So this is your gate valve, okay. So we have to look in this column. So for the gate valve, parallel to this pipe size is 0.9, okay. So this is your equivalent length of this fitting, okay. So for gate valve 0.9 here, enter 0.9. Flexible connection, we are assuming 20, okay. So 20 feet for the flexible connection, okay. So this is just assumption, because it is not given here and we did not found. So as per the supplier, the length is 20 feet. Next one is check valve. So check valve is nothing but the non-return valve. So we have to look for this check swing valve, okay. So we need to look in this column. So this is the equivalent length of the check valve, that means this 8, okay. So how to check this? You have to look in this row, okay, and in this column, okay. So 8 feet. So just enter here, check valve 8. Strainer is, so we look for the strainer. So this is your strainer. So again, this is a screw end, it means 4, okay. So for a strainer it is 4, okay. So this is your equivalent length of the fitting, and this is just multiplying this total equivalent length of the fittings. That means this already multiply with a single length into quantity, okay. So this is the total. We have to add this all, this plus this plus. What you will do, simply apply the formulas it means these all. Okay, enter. So 55.9. okay, total equivalent length. Okay, and then friction factor in psi of water gauge per 100 feet. Friction factor psi of water gauge per 100 feet. Okay, so for 1 psi is equal to 2.3 feet. Okay, so for 100 feet, so what will be your friction factor for 100 feet? This is for the 6.5 for this psi friction factor for 100 feet. Okay, so we need to check the friction factor. Okay, so for 100 feet what would be the friction factor? So this friction factor we are getting in this from this chart. So how to found this? Simply draw one line where these three lines are coinciding. So you can see this in this horizontal axis, this friction loss pounds per square inch feet square inch head per 100 feet of length. So this is for per 100 feet. Okay, so we are getting 6 feet. So okay, so simply enter here 6. Okay, this is 6 we are getting for 100 feet. So for 55 feet what will be the friction factor? Okay, this is for the in psi. So we have to, I have converted into the feet. That means 1 psi is equal to 2.3 feet. So simply multiply this value into 2.3. Okay, so this is for the 100 feet. So what will be the friction factor for 55.9 feet? So what you will do, simply multiply this and divide it by 100. Okay, so 55 into 6 divided by 100. So this is already formula is applied. So this is in feet. So friction factor in feet of water for 100 feet. So how to, this is for the 100 feet. So for 55 feet what will be the friction factor? So 55.9 into 13.8. okay, and divided by 100. So 7.7 feet of water gauge for 55.9 for 55.9 feet. Okay, so we are getting 77.7 feet. Okay, so head loss in feet of water gauge 7.7. okay, so safety factor is 20% we are considering, just assuming. So total head loss, static head is nothing but the vertical head. Okay, so static head is a static head is nothing but the head which is exerted the pressure in the vertical pipe. So vertical pipe, what will be the static head? That means the what, how much is the pipe length of vertical pipe. Okay, so vertical pipe is only 4.5 and 4.5. okay, so this is 4.5 and 4.5, so 9 meter. So here is 9 meter. Okay, so you can see here 9 into 3.28 feet. That means we need a in feet, so I converted here in feet, so 29.5 feet. Residual head is nothing but 1 feet we are assuming. So 1 into 3.28, 1 meter, sorry, 1 meter we are assuming residual head. So multiply into 3.28, so we are getting 3.28 feet. So total head is nothing but the residual head plus a static head. Okay, so total after adding this all these values we are getting 42.1 feet of water gauge. So how to select the pump? Pump selection is based on the flow and head. So what will be the, how much will be the flow? So flow is 4.3 and head is 42. So simply edit it here. 4.3 and head is 42.1 feet. Okay, so how to calculate the HP? So this is your HP formula. Okay, HP is nothing but the GPM into head into a static pressure of water into 3 and divided by 3960 into percentage efficiency. So efficiency is we assuming 65 to 75%. So what you will do, simply enter this above values here. 4.3 is nothing but GPM. Okay, and then head GPM into a static pressure. A static pressure is nothing but the head 42.1 into a specific gravity of water is nothing but 1. Okay, and divided by 3960 is nothing but the conversion factor into HP. The feet of water is this is the conversion factor to convert into feet to HP, feet to HP. Okay, so 0.65 is nothing but the percentage efficiency. Efficiency is 65%. So calculate this. 4.3 into 42.1 into 1. How much we are getting? 181. Okay, so 3960 into 0.65, 2574. Okay, so 181 divided by 2574. I am getting 0.07. Okay, so 0.07 HP. 0.07 HP. You can assume here approximate 0.1 HP. So I think you guys learn how to calculate the pump head booster pump head calculation for plumbing. So thank you for watching my video. Please do subscribe my channel and hit the bell icon as well, so that you can get the notification of my upcoming videos. So thank you for watching my video. Thank you. Bye bye.